Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. We will discuss the question given to this group, which is question 1, question 2, question 3, question 4, and question 5. Me, Anisha Mimi binti Muhammad Arifin, matric number 212761, will proceed with the first question. Okay, the first question is, the area of sphere is increasing at the rate of 18. Calculate the rate of increase of the volume of sphere at the instant when the radius of the sphere is 8. The question given give the info about the dA per dt is equal to 18 and the radius of the sphere is 8. So the question 1 is the rate of increase of the volume of sphere, which is dV per dt. We can use chain rule to get the dV per dt. dV per dr multiply with dr per dt. So we need to find the dV dr and dr per dt. dV dr we can get from the equation from the formula of volume, which is 4 over 3 pi r cube. So we need to differentiate this formula. So dV per dr equal to 4 pi r squared. So we get the dV and dV per dr. So we need to find the dr per dt. We can find dr per dt from the dA per dt. So we can use chain rule from dA per dt, which is dA per dr multiply with dr per dt. So we need to find this dr per dt because we have a complete information about this dA per dt. The question given is dA per dt, and dA per dr we can find using a formula of area of a sphere, which is A equal to 4 pi r squared. So we can differentiate this formula. So dA per dr equal to 8 pi r. So we can insert into this equation. This r is given in the equation, which is 8. So we insert the 8 in the equation, so we can get the dr per dt. The dr per dt is 9 over 32 pi. So the dr per dt insert back into the equation chain rule dV per dt. So dV per dr multiply with dr per dt, which is 4 pi 8 squared multiply with 9 per over 32 pi. So we can get the dV per dt, which is 72 centimeter cubic S minus 1. Okay, that's all from me about the question 1.
Hi, Assalamualaikum. My name is Siti Izureen binti Halim and my matric number is 211422. Okay, today I would like to discuss about the question 2. So the question is, water is dripping out from a container that have been the shape of inverted cone at the rate of 0.8 cm cube as negative 1. If the rate at the base of the cone is 12 cm and its height is 18 cm, find the rate of decrease of the height of the water level of the instant when the height of the water level is 6 cm. So, based on this question, they already mentions and give some information. So, I already list the information and and draw the inverted cone. And I put the information in inverted cone like this is the radius and this is the height for inverted cone 18 cm and 6 cm for the height of the water level. And this dV over dt is negative 0.8 centimeter cube as negative 1. So I make the two dimensions so that I can find what I want to find. So for the first step, I want to find the radius. So based on information given, I can make the ratio. So for the ratio is AB over EC equal to BD over BC. AB over EC, BD over BC. So from this ratio, I can substitute all the information given and I can get the radius is 2 over 3 multiplied by H. Next, for the second step, I want to find the volume of water tank. So this is the formula for volume of cone. So I know that volume of cone. So I substitute the radius that I found in step 1 into the formula. So when I substitute, I can get the answer is 4 pi over 27 multiplied by h power of 3. So I want to make the V volume as dV over dH. So when I make it, I can get the answer is 4 pi over 27 multiplied by H power of 2. So from these equations, I can substitute H equal to C that already mentioned in the equations into the dV over dH. When I substitute, the answer is 18 pi over 3 as the dV over dH. So I will move to the step 3. For the step for the step 3, dV over dH equal to dV over dt multiplied by dt over dH. So from this equation, dV over dH that I already found in step 2, and dV over dt is in the questions. So I want to find dt over dH. So I substitute all the information that I get into the equations, and I want to make dt over dH as the main. So when I move it, I can change the negative 0.8 like this. And then the answer for dt over dH is negative 20 pi over 3. So negative 20 pi or must at negative 20 when I change, so I can get the correct answer. So when I change the place to make dH over dt, so I can get the answer is negative 3 over 20 pi, or for same as negative 0.0478. So for the rate of decrease of the height for water level is negative 0.0478 centimeter cube as negative 2. So that's it for me. Thank you everyone.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin binti Abu Hassan. My metric number is 209995. So now I will explain question number 3. So in this question, it said that a water storage tank A, B, C, D, E, F, G, H is a part of an inverted right square base pyramid as shown in the figure below. So this is the figure. And the complete pyramid OABCD has a square base of size 12 meter and height 15 meter. The depth of the tank is 9 meter. The water is pumped into the tank at the constant rate of 130 meter cube per minute. Suppose that the volume of water V meter cube when the depth of the water in the tank is H meter is given by V equal to 16 per 15 H in bracket H square plus 18 H plus 108 close bracket. So find the rate at which the depth is increasing at the moment when the depth of the water is 3 meter. So in this question, is one the rate of the depth increasing. So which is dH over dt. So the first step is we take the equation that already given, which is V equal to 16 per 15 H in bracket H square plus 18 H plus 108. So we do differentiation with respect to T. So using implicit method. So after differentiation, the answer we got is dV over dt equal to in bracket 16 per 5 H square plus 192 per 5 H plus 576 per H per 5 close bracket dH over dt. So since in the question it said that the depth of the water is 3 meter, so we substitute the H value with 3. So at the end, the answer we get is dV over dt equal to in bracket 1296 per 5 close bracket dH over dt. So since in the question we want the value of dH over dt, so we substitute dV over dt with 1 over 3. So in the final answer, we get that dH over dt equal to 5 per 3888 meter per minute.
Alright, Assalamualaikum everyone. Today I will present question number 4 of this SCL of calculus. Alright, the question states that a cuboid has a square base of size at cm, and the height of the cuboid is half times the length of the sides of its base. So I draw the picture of the cuboid based on the information from the question. And then the question also gives some information. The first one is dx over dt. The question states that x increase at a rate of 0.02 cm per second, which is dx over dt. And then the question also states that when the total surface area is 1,600 cm square. So, and the last one is the question asks for the rate of change of the volume of cuboid which is dV over dt. All right, by using chain rule, we know that dV over dt equals to dV over dx times dx over dt. So we already get dx over dt from the equation, which is equals to 0.02 cm per second. And then we need to get the value of dV over dx. The first step I use is using the surface area, and we know that surface area is the total area of each side of the cuboid, and then we total it, and we get surface area equals to 4x squared. Which is also equals to 1,600, and then we solve this one, and we get x equals 20 cm. And then we know that to get the value of dVdt, we need to use the to get the value of dVdx, we need to use the formula of volume of the cuboid, which is the length of the cuboid times by the height of the cuboid times by the length of the cuboid. Then we get half x times x times x, and equals to half x cubed. Then we differentiate to get dV over dx. We differentiate v in terms of x, and then we get dV over dx equals to 3 over 2x squared. And then we sub the value of x that we get before, 20, and we get dV over dx equals to 600. For the last step, we use the formula by from the chain rule back. Dv over dt equals to dv over dx times dx over dt, and we sub the value of dv over dx and dx over dt. So 600 times 0.02, and we get 12 cm cube per second. Thus, this is the dv over dt, or the rate of change of the volume of the cuboid. All right, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rohaya binti Abdurrahim with method number 210203. So I will be explaining the question number 5. Okay. The height of a cylinder is 3 times its base radius. If the total surface area of the cylinder is increasing at rate of 64 centimeter cube per second, find the rate increase of its volume at the instant when the radius is 18 cm. So first we draw the cylinder, and then we denote the radius as r and the height as 3r as mentioned in the question. And the question also gives the information of dA over dt. And then the question asks us to find the volume at instant when the radius is 18, the rate of increase. So the question asks us to find dV over dt. So first thing, we write down the volume of cylinder, which is V equal to pi r squared h. So the h we can replace with 3r, and then we differentiate the volume with respect to the radius, and we get 9 pi r squared. The r we can replace as the value of r is given, so 18, and we get 2,965. Same goes to the surface area. This is the formula for the surface area. Same, we need to replace the h with 3r, and then we simplify. We differentiate the area respect to the radius, and we get 16 pi r. So we use the concept of chain rule. We want the question asks for dv over dt. So we put dv here and dt here. So the blank we fill with dr. So in order to get dr, we can find dr over dt. So before we get dr over dt, we use the surface area, as the surface area is given from the question. So dA over dt is equal to dA over dr times dr over dt. So dA over dt is given from the question. We just substitute. dA over dr is from the surface area we get just now. So we just substitute, and we want the dr over dt. So we simplify and get dr over dt is 2 per 9 pi. And then we get the dr over dt. So we can use dv over dt is dv over dr. dv over dr is we can get from this, which is 2,965 times dr over dt we can get from this. So 2 over 9 pi. So the final answer we get is 6,648 centimeter cube per second. So that's all for the SCL presentation from group 7. Thank you.